Right, in this video, we're going to talk about suggested homework problems from 7.3. This section covers finding the volume of solids of revolution using the cylindrical shell method. I'm just going to go ahead and get started with the examples here, and you'll see how to do the setup as we go along. So problem 3, y equals x. And I'm glad we start with some pictures here. So we're revolving around the y-axis, and they show the representative rectangle here that is parallel to our axis of rotation. That's what's important. In the disk washer method, our representative rectangles were perpendicular to our axis of rotation. So our representative point here, x, y, we are x units away from our axis of rotation, and y equals x is our function. Dx, x is going from 0 to 2. We have a multiplier of 2 pi on the outside because this is based off of the surface area of a cylinder, which is 2 pi r h. So our function, we're actually going to call that p of x, and this is the distance to the axis of rotation, and the h is h of x, and that will be the height of the representative rectangle. Okay, so this one is 2 pi 0 to 2 x squared dx, 2 pi x cubed over 3, 0 to 2, 2 pi over 3, and this is 2 cubed minus 0 cubed. 2 cubed is 8, 2 pi over 3 times 8, 16 pi over 3, and we're talking about volume, so it's cubic units. Let's look at number 5. And we have y equals the square root of x. Representative rectangle is this way, and we're going from 0 to 4. So volume is 2 pi, 0 to 4. Distance is x. Height is square root of x dx. So this is v equals 2 pi, 0 to 4, x to the 3 halves dx will be 2 pi, x to the 5 halves times 2 fifths, and this x to the 5 halves is evaluated from 0 to 4. So volume is 4 pi over 5 times 4 to the 5 halves minus 0 to the 5 halves. 4 pi over 5. Square root of 4 is 2. This is 2 to the 5th minus 0 is 4 pi over 5 times 32 over 1 is going to be 128 pi over 5 cubic units. So looking at number 13, and we're going to have our rectangles going the other way now. We're also going to have some more complicating factors with our problems, such as with this one. Just look at the picture that we're revolving this way, but our height does not I'll show you what we're going to do. So we have to think about right minus left here because we're not going from 0 to something now. We're starting somewhere and going out to a number here. So y equals x. So we have x as a function of y, x equals y, and we have 2 pi integral. So our representative rectangle is going this way, and our distance from our axis of rotation is going to be y. Now our height of our rectangle is going to be right minus left, 2 minus y dy. So this is our big X value minus our little x value. So this is x equals 2. This was x equals y, 2 minus y. All right, so 2 pi, and then y is going from 0 to 2. We look at our picture, 0 to 2, 2y minus y squared dy. This will be 4 pi 0 to 2 y dy minus 2 pi 0 to 2 y squared dy is 4 pi over 2 y squared, 0 to 2 minus 2 pi over 3 y cubed, 0 to 2. 2 goes into 4 2 times, 2 pi, 4 minus 0 minus 2 pi over 3, 8 minus 0, 8 pi minus 16 pi over 3, that's 24 pi over 3 minus 16 pi over 3 is 8 pi over 3 cubic units. So now at number 15. And looking at the picture, we have 1/2, 1, 3/2, 2, and 1/2, 1, 3/2, I'm sorry, 1/4, 1/2, 3/4, and 1. So this is at 1, 1, and 2, 1/2. Come down like so, and down like this, and then we have this rectangular piece and this curved piece. So we've got 2 intervals, and we're going to use horizontal representative rectangles here. So 2 pi, let's start at the bottom, go from 0 to 1/2, and right minus left, and the distance to the representative rectangle is y plus 2 pi, and then we have 1/2 to 1 on y. We again are y away from our axis of revolution, and right minus left is 1 over y. If y is equal to 1 over x, then x is equal to 1 over y, minus left-hand side is 1 dy, 2 pi 0 to 1/2 of 2y minus y, I'm sorry, 2 minus 1 is 1, y dy plus 2 pi 1/2 to 1. This is where I want to distribute 1 minus y dy. There we go. 2 pi y squared over 2, 0 to 1/2 plus 2 pi 1/2 to 1 dy minus 2 pi 1/2 to 1 y dy. 1/4 minus 0 plus 2 pi y 1/2 to 1 minus 2 pi y squared over 2. 2's will cancel, 1/2 to 1. That's pi over 4 plus 2 pi times 1 minus 1/2. It's 1/2 times 2 becomes a 1 minus pi times 1 minus 1/4 is pi over 4 plus pi minus 3 pi over 4. 1 minus 3 pi over 4 is pi over 4, and pi over 4 plus pi over 4 is pi over 2. And that's going to be cubic units. 27 will be our next problem. It's just a setup problem. We are not supposed to solve it. So 27 gives us the function y minus 2 squared equals 4 minus x, and gives us the picture here. This sideways parabola that has a vertex at 4, 2, and y-intercepts at 0, 4, and 0, 0. We're going to revolve around the x-axis, and we just want the region between the y-axis and the curve that's shaded there. Do you want representative rectangles that are vertical or horizontal here? It makes more sense to me to choose horizontal rectangles that are going to touch an axis of x equals 0 and always touch the curve on the right. So I'm going to use the shell method, because that's going to choose a rectangle that's parallel to my axis of rotation. So 2 pi, y goes from 0 to 4. Distance here to my representative rectangle is y, and then right minus left is, let me solve for x here. X is equal to 4 minus y minus 2 squared. So that equals 4 minus y squared minus 4y plus 4. So x is equal to 4y minus y squared. So 4y minus y squared dy. And that's enough setup there for that one to be able to get the answer. If you do want to know what the answer is so you can keep working on this, I'll show you that you can use the calculator here. Integration 0 to 4 of 4x squared minus x to the third. Once I distribute that y through, it's 4 y squared minus y cubed y, and math. Answer to fraction. This will be 2 pi times 64 over 3 is 128 pi over 3 cubic units for my answer. That's just for you to be able to check yourself later if you want to keep working on this. So the goal was just for setup, not to get to the answer. All right, let's continue with number 31. X to the 1/2 plus y to the 1/2 is equal to a to the 1/2. X equals 0, y equals 0. Let's take a look at what that graph might look like. When x is 0, then y is going to be equal to a. So we have a point 0, a. When y is 0, x is going to be a. So we have a point a 0. And then I'm going to pick an a value that has a perfect square here, or that is a perfect square, like 4, so that the square root of 4 is going to be 2. 2 minus the square root of x, and I'm going to square it. So like so, and I'm interested in this piece of the graph between y-intercept and x-intercept, that it curves down like this, but we're told that we're between the x-axis and the y-axis here, so we're only interested in this part of the graph right here. We're not interested in the part that goes back up there. So part A says we want the axis of revolution to be the x-axis, y equals 0. So we're going to like so, and let's use the shell method here to make a left to right rectangle that touches the y-axis. So that's 2 pi, and then this is 0 to a, and the distance to the point there is going to be x times, and then solving for y as a function of x, that will be a to the 1/2 minus x to the 1/2 quantity squared dx. I'm sorry, I want this as a function of y, like that. So, because I'm doing horizontal rectangles. So y is going from 0 to a, and y is the distance between my axis of revolution here and my rectangle. And then my height of my rectangle is a to the 1/2 minus y to the 1/2 quantity squared. All right, let's go ahead and solve this. A minus 2a to the 1/2 y to the 1/2 plus y dy, 2 pi 0 to a y minus 2a to the 1/2 y to the 3/2 plus y squared dy. It's going to be 2 pi and then a to the y squared over 2 from 0 to a minus 4 pi times a to the 1/2 y to the 5/2 times 2/5 0 to a plus 2 pi over 3 y to the third from 0 to a is 2's go out, and this is a cubed pi minus 8/3 a cubed pi plus 16, no, plus 2/3 a cubed pi. This is not thirds, this is fifths. So 1 minus 8/5 plus 2/3. 1 minus 8/5 plus 2/3. Math. Answer to fraction is 1/15 cubic units. Okay. Part B is, let's draw this figure again. 0a, a 0, decreasing and connecting here, shaded region. Now we want to revolve around the y-axis, which is x is equal to 0. So if this is my axis of revolution here, I could again use the shell method and make rectangles that are parallel to the axis of rotation, and it's really not going to change anything. We're going to get 2 pi, and now x is going from 0 to a, and this is going to be distance away is going to be x times, and now this is a to the 1/2 minus x to the 1/2 squared dx, which is exactly what I had up here for part A, but with a change of variables. Just want you to see that this step and this step are identical, just that all of my y's become x's. And so this is going to have exactly the same answer of a cubed pi over 15 units cubed. So no need to do all that work again. Part C, let's look at the picture here. We want the line x is equal to a. So now I'm going to revolve around the line x is equal to a. And that's going to give me 2 pi, interval 0 to a on x, and our distance from our axis of rotation is a minus x, and then we have the same function a to the 1/2 minus x to the 1/2 squared dx. This is 2 pi, 0 to a, and a minus x times a minus 2a to the 1/2 x to the 1/2 plus x dx. 2 pi, 0 to a squared minus 2a to the 3/2 x to the 1/2 plus ax minus ax plus 2a to the 1/2 x to the 3/2 minus x squared dx. These are equal and opposite, so they zero each other out. 2 pi a squared x from 0 to a minus 4 pi a to the 3/2 x to the 3/2 times 2/3 0 to a plus 4 pi a to the 1/2 x to the 5/2 times 2/5 0 to a minus 2 pi over 3 x to the 3rd 0 to a. It's going to be 2 pi a cubed minus 8/3 pi a cubed plus 8/5 pi a cubed minus 2/3 pi a cubed. Let's just check here. 2 -8 plus 8/5 minus 2/3. So 2 minus 8/3 plus 8/5 minus 2/3. Math, answer to fraction is 4/15. Cubic units. And that's it for that problem. On to number 41. Not only are we going to choose the appropriate method for 41, but we're going to compare our results for which one gives us the biggest volume, middle volume, and least volume. So 41 gives us a picture here to help us out and tells us that the function is y equals x to the 2/5. X goes from 0 to 4. And this point up here is 4. 4 to the 2/5, whatever that is. So 5th root of 16. Not a nice number, not a number that I want to use as a bound. So I'd like my bounds to go on x from 0 to 4 if possible. So I'm going to use the disk method for part A, which tells me to try to revolve around the x-axis. So disk method is going to be pi r squared and this is 0 to 4. And so this is pi 0 to 4 of x to the 4/5 dx. It's pi and then x to the 9/5 times 5/9. 0 to 4 is 5 pi over 9 times 4 to the 9/5. And that's pretty gross. Got 5/9 times 4 to the 9/5 is about 6.7365 pi. All right, now for part B, we'd like to go about the y-axis instead. So I'd like to still keep my rectangles vertical here. So I'm going to use the shell method now. That's going to be 2 pi, 0 to 4 distance away from the axis of rotation is going to be x, and this is going to be 4 this is going to be x to the 2/5 for my height, dx. So this is 2 pi 0 to 4 x to the 7/5 dx. So this is 2 pi x to the 12/5 times 5/12, which is 5 pi over 6 times, this is 0 to 4, it's 4 to the 12/5. So this is 5, 6 times 4 to the 12/5 is approximately 23.2147 pi cubic units, and part C is going to be a lot around the line x equals 4. So setup for C will also be shell 2 pi 0 to 4. This time we're revolving around this line over here. So distance to my axis of rotation is 4 minus x, x to the 2/5 dx, and this is 2 pi 0 to 4, 4x to the 2/5 minus 2 pi 0 to 4, x to the 7/5 dx. So 4 can come out. That 2 is an 8, so 8 pi x to the 7/5 times 5/7, 0 to 4 minus 2 pi, and this is x to the 12/5 times 5/12, 0 to 4, so this is 40 pi over 7 times 4 to the 7/5 minus 5 pi over 6 times 4 to the 12/5. It's going to be 40 over 7 times 4 to the 7/5 minus 5 over 6 times 4 to the 12/5 is approximately 16.5819 pi. So if I look at my answers from A, B, and C now, that the smallest was part A, and then part B, part C, and then part B was the greatest of them, that 6.7, smaller than 16.5, smaller than 23.2. So there we go in order. A gave the smallest volume, C gave the bigger volume than A but smaller than B, and B was the biggest volume of the three. let's continue with number 47. So we have the function y is equal to 1/2 x squared, y equals 2. I'm only going to draw one quadrant of this because it's symmetric to, it's an even function that's symmetric to the y-axis, and I'm revolving around the y-axis. So I don't want to double the volume that I'm supposed to have. If I take this part and revolve it all the way around the y-axis, I get everything for my volume. So this point here, when y is 2, then x squared is 4, and x is 2 since I'm on the right hand side here. If I need that, this point is 2, 2. All right. I'm going to revolve around the y-axis. I'm going to pick a representative rectangle that is parallel to my axis of rotation, so I can use my shell method, and this is going to be 2 pi as x goes from 0 to 2. The distance here is x, and now I have a upper minus a lower here, so that's 2 minus 1/2 x squared dx. So this is, volume is 2 pi 0 to 2, 2x minus 1/2 x cubed dx. So the volume is 4 pi integral 0 to 2 x dx minus half of 2 is 1 pi 0 to 2 x cubed dx. That will be 4 pi x squared over 2 from 0 to 2 minus pi over 4 x to the 4th from 0 to 2. Volume is 2 pi times 2 squared is 4 minus 0 minus pi over 4 times 2 to the 4th is 16 minus 0. So that is going to be 8 pi minus 4 pi is 4 pi, and this is my total volume before drilling So I'm going to drill a hole that removes 1/4 of the volume. So 1/4 of this volume is going to be pi. And again, use my method of cylindrical shells. And now go back to this form right here, 2x minus 1/2 x cubed dx. Pi's will cancel, and I'll have 1 is equal to 2, and then this is 0 to x naught, 2x minus 1/2 x cubed dx. So that is equal to 4, 0 to x naught, x dx minus 1 x cubed, 0 to x naught dx. So 1 is equal to 4 x squared over 2, 0 to x naught minus x to the 4th, 1/4, 0 to x naught. So 1 is equal to 2 x naught squared minus 1/4 x naught to the fourth. I don't like that fraction there, so I'm going to multiply everything by 4. Bring everything to the left. And before I do any work, I want to think about some things here. So my x naught, which is my radius that I'm going to drill, needs to be a positive number, but it has to be less than this width here, which is 2. And I'm solving for x naught squared with this, so square these values. X naught squared is going to have to be between 0 and 4. So x naught squared is going to be equal to, I'm going to use my quadratic formula, 8 plus or minus the square root of b squared is 64, minus 4ac, that's 16, over 2 times 1, that's 2. It's 8 plus or minus root 48 over 2. X naught squared is equal to 8 plus or minus, this is 16 times 3, so root 16 is 4, root 3 over 2, that's 4 plus or minus 2 root 3. I just said that x naught squared has to be between 0 and 4, so it can't be 4 plus something. X naught squared has to be 4 minus 2 root 3. Let's verify that that is greater than 0, and it is. So now our x naught is going to be the positive 4 minus 2 root 3, because x naught has to be greater than 0, and so I can't have the negative option there. And I actually wanted the diameter, not the radius, so I need to multiply by 2 to get my final answer. So 2 square roots of 4 minus 2 square roots of 3. It's going to be approximately 1.464 units. And those are linear units because we're talking about the diameter of the hole that we are drilling. All right, that's it for this video. We will come back next time and talk about suggested homework problems from 7.4, which will discuss integrals for arc length and surface area. See you for the next video.